Astronomical Society. I know we have some new members who are here. You'll have to excuse my setup for the people who are getting here early. I've been out in my backyard, my telescope's behind me, and what we were trying to do is put an image of the moon up there. Maybe towards the end of the meeting I can do that also. So I'd like to welcome you all here. Been an amazing summer, everybody. I miss all of you. Because we're not at Muddy Run, there's not a lot of chance for us to gather much anywhere. I'll give a quick heads up on the Franklin Institute. There's nobody there in the volunteer staff, and none of the people who had put us into the Franklin are there to put us in. They have not started the volunteer program. They are not going to possibly let any of the volunteers in so they can figure out how to do that safely. And they're only open about, they're Wednesday through Sunday right now. So everything's kind of on hold right there. There is nobody to contact, so we're not really contacting anybody at this point. And that's why this meeting is going to be on a Zoom platform. So again, if you're just joining in the background, I'm Ted Williams. I'm the president of the group. I'm standing in as president because our officers' terms expired. And what we did is to at least get this organization through this COVID period. We just kind of kept our officers in place for the time being. I just got back from Wyoming. A lot of you know about that. Nobody from the club went out with me, but the lodge sold out one of the nights. It was a very lucrative trip, and I'll tell you right now, they've already invited me back again next year. In fact, Fern, it was the very first night that the people raved so much about the Star Tour out in the meadow. Jim had approached me. So we're going to do it again next year. And I think it's going to be the weekend after Labor Day once again. So same exact weekend. So mark your calendars. Hopefully, you know, it'll be safer to travel and more of you might want to come out. What is interesting is nobody returned who was there previously. So it was a whole new cast of characters I got to meet each time. It'll be interesting when this new cast of characters wants to come back again next year too. We had some very happy customers up there. When I came back, I invited everybody who was an Astrocora. If you're not coming out to those are we do two things now. We do events and we do forums. Tonight is an event. It's a special night because we have a guest speaker with us. And on a night when we are doing a forum, we have a topic and we get together and we talk about astronomy. So those of you who are new, if you see those Astrocora nights, you should be getting invitations to them. You're more than welcome to join in. You don't have to know anything to join. You can just sit and watch. And what I'll do is towards the end of the meeting, I'll share with you some new ideas we have to beef up that format a bit, which might be interesting to a lot of you. So I'll stop there for a second. Again, we have a guest speaker tonight. Robert Naeye was with us almost 2 years back, and he came to the Franklin Institute with us at that time. And it was a cigar from another, wait, give me the title, Robert.
Bizarre cigar from another star.
Yeah, okay, I got the cigar from another star, yeah. But it was a great topic. He was a great talker with us, and he was the chief editor of, okay, I don't want to get it wrong, so is it Astronomy or Sky? You were Sky and Tel.
Yeah, I was editor-in-chief of Sky and Telescope, but I've also worked as a senior editor for Astronomy.
So he's got a lot of background, and he's very good. He's very well published, and he gave an amazing talk with us last time. So we invited him to do two things because we're looking for local talent. And at Muddy Run, we're going to be kicking off a series of speakers that we're going to actually do people coming in from their different observatories. So Robert's going to talk in October because we usually have a special event in October every year at Muddy Run. He's going to be talking in October. He'll do the same talk that we're doing tonight. Oh, by the way, Dan, can you start the record button or do I have to start it?
Already ahead of you there.
Oh, okay. So I'm being recorded. Thank you so much. Got it, because I just thought, oh, wow, we missed that one. All right, so good. So Robert was with us back then. He's going to come out with us, and yeah, I'll throw the opportunity out to you too, Rob. If you wanted to come out and do that live, you know, from the park, we mask up and we can sit in the dome and try it. And if you don't want to, perfectly okay. And we'll wait till we get closer to that and see how you feel. We'll talk privately about that also.
It's closer to me than it is to you. I live in
yeah,
so it's closer to me.
but people are looking for an excuse to get out now. So,
Yeah.
and you might be in that frame of mind. If you do come out, just know we mask up in the dome. We do everything as safe as we can. We don't have more than 3 or 4 people ever in the dome at one time. And we just have one person filming you, and you'd be in there also, and that'd be it. Just so you know. Anyhow, so it's great that he's with us here, and he's got another great article he's put together. And it's funny too, because it came up recently in the news, and he's going to address that also. So I don't want to give anything away, because I don't want to steal his talk from him, but I think we're right on time there for this one. So ladies and gentlemen, a return guest speaker with us, and one who I know you're going to enjoy tonight, and it's Robert Naeye. Robert, take it away.
Okay, great. Thanks. Can everybody see my slide here?
Yeah.
Yep.
So we're good. 3 roads to extraterrestrial life. Everybody can see it okay?
Yep.
Yes.
Okay, great. Well, I'll just jump right in. So, first of all, I just want to thank Ted and Al for inviting me to give the presentation tonight, and Ted for connecting with me earlier today to make sure all the technology would work. And it's a really pleasant evening out there, so I want to thank all of you for tuning in tonight. I wish I could be there in person like I was 2 years ago, but it's good to connect with the RAS again, even if it's just virtually. So I've got a lot of ground to cover in about 30 to 35 minutes, so I'm going to just jump right in. So as Ted mentioned, my talk tonight is based on a cover story I wrote for the September 2020 issue of Astronomy magazine. I'm not sure if it's on newsstands right now, but you can always order it online. So if you're interested in this topic, you can, read the article. There's also an accompanying web article I wrote as well that actually has material I'm not going to really discuss tonight, but which might be of interest to you. So my topic tonight is how scientists might find life on other worlds. And I think we all know for centuries, scientists have discussed and debated and deliberated about the prevalence and nature of extraterrestrial life. And the public, of course, is very interested too, given the popularity of movies and stories that depict alien creatures like E.T., Star Wars, Close Encounters, etc. But despite all of this interest and speculation, I like to liken astrobiology to string theory. It's a science whose subject matter has not been proven to exist. We really don't know who or what is out there, or whether life is common or rare. People talked about it, written about it, but we really don't know. So what we need to do is we need to turn astrobiology into an observational science, which means we need to find out what's up there. So as my astronomy article explains, scientists are taking 3 different roads or approaches to search for extraterrestrial life. So imagine this road veering to the left is searching in the solar system. Number 2 is probing the atmospheres of exoplanets. Those are planets orbiting other stars in search of biosignatures. And the really fun part is the 3rd road off to the right is the search for technosignatures from advanced civilizations. So I'll talk about that toward the end. I want to make it clear though, this is not a race or competition. We don't know how common life is, or it's impossible to predict how soon we'll find it, or who will make the first detection on life on another world, or how it will be made. We just don't know. But I can tell you that our technology is getting better and better. So if life is relatively common, we might make the first definitive detection in the next 10 to 20 years, hopefully in my lifetime. I'm 57 right now. I'm hoping this happens in my life. So of course, all of you are wondering, well, haven't we already detected extraterrestrial life? And the answer is no, at least nothing that's been proven or confirmed. So I think it's probably a lot of you have read, last week an international team of astronomers announced the detection of the molecule phosphine in Venus's thick atmosphere. That's pH3. So this slide shows the 2 spectral signatures, one in white, one in blue, of 2 different telescopes superposed on an image of Venus. the two different telescopes that detected this spectral signature. But I need to emphasize that, and I listened to their press conference, this discovery team made it very clear they did not detect life on Venus. What they said they detected is they've detected phosphine gas at a fairly high level of confidence. Now, on Earth, phosphine gas comes either from microbes or human industrial activity. And the team tried to rule out all known processes that are non-biological on Venus that could produce this observed phosphine. But this phosphine was found in an atmospheric layer about 30 to 40 miles above the surface, where, as far as we can tell, there's virtually no water, and it's dominated by clouds made of sulfuric acid. So it could be some kind of chemical reaction that we don't see on Earth that's producing the phosphine. We really don't know. So basically what we have right now is the detection of phosphine with no explanation for what is producing it. Life is one of the possibilities, but right now we just don't know. It's going to take follow-up missions to Venus, maybe like a balloon mission or some kind of sample return of gas in the atmosphere 30 to 40 miles high before we can answer this question. So I'm just going to say that this is unresolved right now. So I'm going to really start off with the solar system and start off with Mars. And I think, as all of you know, probably many of you have been observing and imaging Mars in recent weeks, is, you know, the planet comes relatively close to Earth every 2 years or so. And it makes it relatively easy to observe, makes it relatively easy to observe with spacecraft. And for long stretches of history, many people, including learned scientists, just assumed that Mars is inhabited, maybe by intelligent beings or by a vegetation. But the Mars, you know, the NASA spacecraft that flew by Mars and then orbited Mars in the late 60s into the 70s, showed that Mars's surface is cold, dry, barren, and completely lacking in any obvious signs of life. But here we see two orbital photos from Viking that show channels that look suspiciously like channels, streams and rivers on Earth carved by water. And I think, as probably many of you also know, that spacecraft, observations from the surface by landers and especially the NASA rovers have really proven, I think beyond all doubt, that liquid water once flowed on Mars. So, on Earth, where we find water, we find life. So this makes the red planet a plausible host for past or current life. So in 1976, two Viking landers touched down, two NASA missions, the very first successful landings on Mars. On the left, we see a model of a Viking lander, and on the right, we see an image from Viking 1, that big boulder in the distance is named Big Joe. That remains my favorite rock on Mars. Now, both Viking landers came equipped with mechanical arms that you can see here in the image. They scooped up soil samples, brought them inside the lander, and then each lander had 3 experiments to search for life, to look for metabolism, basically, and also an instrument to look for organic material. Now, this is what's really interesting. One of the biology experiments, the labeled release experiment, returned from both Viking sites that were 4,000 miles apart, returned data highly consistent with the interpretation that there's life on Mars. The problem is the other 2 experiments were negative, and the experiment to detect organic chemistry came up negative. So most, but not all, scientists concluded no organics, no life. Therefore, the positive results of this labeled release experiment, they were attributed to some kind of active chemical agent in the Martian soil. But I want to make it clear, and I've talked to astrobiologists about this, it's unclear. It's possible that we've already discovered life back in 1976. I actually find this result a lot more compelling than the Venus results announced last week. And what I'm really disappointed is that NASA has taken a very conservative approach. They don't want to repeat ambiguous biology results. So NASA has never since sent a dedicated life detection experiment to Mars to follow up these results. Now, many of you probably also remember, go back to 1996, a team of NASA and Stanford scientists announced that they had found chemical signatures of past Martian life inside this meteorite, ALH 84001, which definitely came from Mars. And you can see on the right, they even found these little incredibly tiny tube-like structures that they interpreted as possible fossilized nanobacteria. Now, this life would have dated back several billion years ago, back to when Mars had water on its surface. Now, these claims remain controversial to this day because all the signs of life can also be explained by non-biological, just regular chemical processes. So I would say that this is still kind of an open question. Now, much more recently, telescopic observations from Earth and measurements on Mars from NASA's Curiosity rover have detected trace amounts of methane in Mars's thin atmosphere. And as you can see in this illustration, that methane rises and falls with the seasons. Now on Earth, 95% of the trace amounts of methane in Earth's atmosphere are of biological origin. The problem is, of course, once again, there's a number of chemical or geological processes that can produce methane that don't have anything to do with life. Also, this is amazing. Last year, the same Curiosity rover also discovered free oxygen, trace amounts, but there's trace amounts of oxygen in Mars's atmosphere, which rises and falls in tandem with the methane. And of course, on Earth, almost all the methane in Earth's atmosphere also comes from biology. So we have these tantalizing results, but right now we can't say for certain whether we found life on Mars. So in less than 2 months ago, on July 30th, NASA launched its next Mars rover, Perseverance, or they call it Percy for short, to go to Mars, and it'll land in February 18th of next year. So here's a piece of art depicting Percy on the surface. Now, Percy's going to land in Jezero crater, and you can see that inside this crater, it's not that little crater in the middle, it's kind of the big crater that's kind of offset to the right. Inside this crater, you can tell, it's obvious from the orbital image, that this is an ancient river delta. So Curiosity should come across lots of rocks that formed in liquid water billions of years ago. Now, despite what NASA says, Percy carries not a single instrument that's really dedicated to searching for life, or really that's capable of detecting microscopic life. It's sort of being touted as this life mission, but it's really not. But what it will do is collect rock and soil samples for later return to Earth. So here's a nice artist rendition of a sample return mission that NASA and the European Space Agency are planning right now. This thing would, if it goes on schedule, it depends on funding and politics as much as science, we'll have samples back on Earth in the 2030s. And as one of the team members I quoted in my astronomy article, Jim Bell from Arizona State University, he said that as far as he's concerned, Percy's mission won't be complete until its samples are brought back to Earth. So according to the current mission architecture, NASA will provide a rover that'll go to Mars, collect the samples that Percy's gathered, put them on a little rocket, blast it into Mars orbit, and then the European Space Agency will provide a spacecraft that'll rendezvous in orbit with this sample vehicle and then return it to Earth. I mean, this is obviously an extremely challenging mission technologically, but if it works, we could have Martian samples that scientists can study in our best laboratories right here on Earth sometime maybe 10 or 15 years from now. If these samples contain traces of life, past or present, we'll answer the life question. If not, doesn't rule out life on Mars, but it could prove life, current or past life on Mars. Now, the European Space Agency is planning its own rover named Rosalind Franklin. She was the great British scientist whose X-ray imaging in the 1950s made possible Watson and Crick's discovery of DNA's double helix structure. So this rover was actually originally scheduled to launch earlier this year and arrive early next year, but the Europeans ran into technical problems and then COVID hit, so they had to postpone the launch until 2022. So it's going to land in an ancient Martian lake bed. It'll carry a suite of cameras, spectrometers, and a drill. It can dig up material from 2 meters below the surface, bring it on board. It'll be crushed and into a powder and heated. And there are going to be 4 experiments that will study this material for signs of organic compounds and biosignatures of past or current life. So it's possible that if Mars does have life, the Europeans could beat NASA to the punch, and NASA will have a big egg on its face for not sending a life detection experiment years and years ago. Now, if these robotic missions cannot resolve the life question, they really can't prove that there's no life, they can only prove that there's life, then perhaps future human explorers can dig down into the underground aquifers and other locations that are thought to be the most likely to harbor life. And it really might require a sustained human presence and exploration for many years to really prove one way or another if Mars is a living or a dead planet. And you know, if astronauts or anybody finds evidence of life on Mars, it would be an incredible discovery. If Martian life turns out to have some kind of evolutionary linkage to terrestrial life, it could imply that life originated on one planet and was transported to the other inside a meteorite like ALH 84001, or it could imply that life on both planets were seeded from a common source. But what if Martian life is completely unrelated to terrestrial life? That would strongly suggest that life arose independently on 2 separate worlds. And that would imply that life will arise wherever conditions are favorable. And that in turn would imply, I think, that our galaxy, just the Milky Way galaxy alone, has billions of life-bearing planets and worlds, as I'll explain later. So I want to turn now to the icy moons of the outer solar system, and we're going to start with Jupiter's 4th largest moon, Europa. Now, the 2 Voyager spacecraft, 1 and 2, when they flew by and they saw how much they were deflected by its gravity, they could get a bulk density measurement. We could measure its size and mass, therefore we can calculate its density. And that implied that there's a very thick layer of liquid water underneath this moon's icy crust. So that was really interesting. And in this picture, you see cracks all over the surface. You see very few craters. The cracks imply that there's liquid material from under the surface that's getting up to the surface. So these were very tantalizing that there could be a lot of liquid water on Europa. So starting in 1995, NASA's Galileo spacecraft went into orbit around Jupiter, and it had a number of close flybys of Europa where it took spectacular images like this one. And what you see here is you see these kind of chunks that look like kind of ice rafts that look like they're floating on top of some kind of watery medium. Galileo had a magnetometer that discovered an induced magnetic field on Europa, which indicates that there's a subsurface ocean that's salty. And even more intriguing, Galileo discovered organic material on the surface. All these are really amazing discoveries. And so since then, scientists studying Hubble Space Telescope data and archival Galileo data have found evidence that Europa is shooting watery plumes into space. So you add all of this together, there's abundant evidence for a thick ocean of water on Europa. In fact, the model suggests that this ocean contains more water than all of the water in Earth's oceans combined. And this ocean is almost certainly in contact with a rocky layer below. And we also know Europa is tidally heated from being tugged upon by Jupiter and its 3 other large moons. So Europa has all the ingredients for life as we know it. It has liquid water, organic molecules, and energy. So it's really not difficult to imagine hydrothermal vents on Europa analogous to those on Earth's seafloors, which fuel rich, complex ecosystems in the complete absence of sunlight. So NASA is planning a mission in the early 2030s called Europa Clipper. Now it's going to orbit Jupiter, but it'll fly by Europa 44 times over several years. It'll image almost the entire surface at high resolution. It'll measure the ice thickness so scientists can identify where the ice is relatively thin. It'll also fly through these plumes I talked about and measure their composition. I don't think that Europa Clipper will discover life, but it will pave the way, I hope, for a future lander. So this lander will search for the surface for signs of life, but more important, it'll either melt or drill its way through the ice and deploy a submersible to explore the ocean and look for signs of life. So this would be an incredibly exciting mission, but it's probably a long way off. My guess would be it would launch in the mid to late 2030s at the earliest, but it would be an amazing mission. I want to turn briefly to now Titan. Scientists are keenly interested in this largest moon of Saturn because it has a thick atmosphere that has similarities to Earth, both in terms of composition and pressure. And it has lakes and rivers on the surface where the liquid is not water, but methane. So methane is CH4, it's an organic compound. The problem is that the surface temperature is minus 290 degrees Fahrenheit, which is probably too cold for life as we know it, but there could be hydrothermal areas that are warmer where you could imagine life. There could also be a water ammonia layer below the surface that could sustain life. So NASA has approved an incredibly exciting mission called Dragonfly that's basically a rotor craft or kind of a robotic helicopter that's going to fly in Titan's atmosphere. So it's going to study the surface composition, atmospheric conditions, geological processes, scheduled to launch in April 2026, arrive in December 2034. So you can imagine flying a helicopter in an atmosphere of another planet with very cold temperatures is another incredibly challenging mission technologically. But if it works, it could conceivably find evidence for non-water-based life, life 2.0, life unlike life on Earth, or at least help scientists better understand the origin of life. So now I want to leave the solar system behind and turn to exoplanets, planets orbiting other stars. And I checked the website exoplanets.eu just a few hours ago, and it said that as of today, there are 4,340 known planets orbiting other stars. So that's pretty amazing. That's 542 times as many planets orbiting other stars than we know orbiting the sun. So you can do statistics on what we found, and we can say very confidently that the Milky Way galaxy has hundreds of billions of planets, and could be as many as 1 trillion. You add the moons in, and there's just an enormous number of potential habitats for life. But even the closest exoplanet is 4.2 light years or 25 trillion miles away. So you might be wondering, we're not going to visit them anytime soon. How can we study them for signs of life? And this illustration explains how it can be done. We can probe exoplanet atmospheres, and we're doing it right now by looking at transiting exoplanets, the planets that cross in front of the disks of their host stars once every orbit as seen from Earth. So as the planet transits its star, some of the star's light passes through the upper atmosphere of the planet, and some of the molecules and elements in that atmosphere will absorb some of the starlight. So the astronomers can look at the spectrum of the star when the planet is in transit and out of transit, and the spectral lines that show up when the planet is in transit act like a fingerprint, revealing different chemicals in the planet's atmosphere. So these spectral lines could reveal chemical indicators of life known as biosignatures or biomarkers. Now here we see the spectral signatures of Venus, Earth, and Mars as they might be seen from alien astronomers from outside the solar system. Now, when they would look at Earth, what would jump out to them immediately is that very clear spectral line for O3. That's oxygen molecule called ozone consisting of 3 oxygen atoms. They'd also be really interested in the water feature, which would show up quite abundantly. That would probably immediately, the alien astronomers would probably think there's a very good chance this planet, of course they wouldn't be calling it Earth, who knows what they would call it, but they would say, oxygen is a highly reactive chemical. If it's not constantly replenished, it would disappear from Earth's atmosphere within a few centuries. So it has to be constantly replenished. And certainly on Earth, almost all the oxygen is from photosynthesis and biology. So they would probably say this is a extremely interesting planet, probably has life. Now, if they look at Venus and Mars, both of those planets have atmospheres dominated by CO2, carbon dioxide. There are so many different chemical and geological processes, including volcanism, that can produce CO2 that have nothing to do with life. So they would say, well, we can't rule out life on these 2 planets, but they're a lot less interesting than that middle of the 3 planets. There's another way we could find biosignatures as well, and that is to get spectrum of other planets and find combinations of chemicals that should not exist together in the atmosphere, where they would destroy each other, or one or the other would be removed. And so the only thing where you could, the most likely explanation is life, to give you that particular combination of chemicals. So astronomers have already used this transit spectroscopy method to discover dozens of chemicals in exoplanet atmospheres, including water vapor and CO2. But it's generally thought by the community of astronomers that it'll require the next generation of telescopes to really find convincing biosignatures. But the good news is that this next generation of telescopes are right around the corner. One of them is the James Webb Space Telescope, which NASA is scheduled to launch next year, a little over a year from now. It has a 6.5 meter mirror, more than twice the diameter of Hubble's primary mirror, and it'll be optimized for infrared observations, which could reveal water, ozone, methane, and CO2 in the atmospheres of transiting exoplanets. So it's going to observe stars within a few dozen light years of Earth that have transiting planets, and astronomers are going to especially concentrate on planets that orbit within the habitable zones of their stars. Now, I think even better is that international consortiums are currently building 3 gigantic land-based telescopes pictured here, all of which are expected to come online before the end of this decade. So counterclockwise from the upper left, we have the 30-meter telescope, the giant Magellan telescope, and the European Extremely Large Telescope. So they all have primary mirrors, 25 to 40 meters in diameter. I mean, think about that. The largest ground-based telescope right now has a mirror about 10 meters in aperture. So these are giant telescopes. They're going to be equipped with state-of-the-art instruments. So they're going to be able to probe a greater number of transiting exoplanets with better spectral resolution than JWST. Because they're located on Earth's surface, although in very dry areas, they're really going to be optimized more for optical observations rather than infrared. So they're going to be capable of detecting biomarkers like O2 and O3 and water vapor. So if life is common in the galaxy, there's a decent chance that one or more of these 3 telescopes will detect biosignatures. Astronomers are also developing telescopes that use advanced coronagraphs and other techniques that can blot out the light of a host star. The star is going to outshine the planet by roughly 1,000,000 to 1, depending on, you know, the factors of the system and the wavelength. So astronomers need to reduce the star's glare to really study planets that don't transit their stars. So here's what's called ExoLife Finder, ELF. An international team is working on the technology right now. It's going to be a 20 to 30 meter telescope depending on funding. And if it is built and works according to specs, it can probe deep into exoplanet atmospheres and even take images of clouds and surfaces. I mean, it could theoretically image oceans and continents on another planet outside the solar system. And of course, this includes planets that don't transit their stars, which constitute the vast majority of planets in our galaxy. So now for the third and final part of my talk, I'm going to talk about the search for extraterrestrial intelligence, or SETI, but I'm going to also expand this a little bit to talk about technosignatures, which are signs of advanced civilizations that are either modifying their planets or their interstellar environments in ways that our advanced telescopes could detect. So I think, as many of you know, since the early 1960s, astronomers have been listening for alien radio signals using radio telescopes or arrays like the Allen telescope array that we see here. This has been going on for quite a while. The projects right now are mostly piggybacking on routine radio observations of stars and galaxies. The most sophisticated and advanced radio SETI project going on right now is called Breakthrough Listen. It's funded by the Israeli-Russian billionaire Yuri Milner, who we see at the upper left. So it's using these 2 large telescopes, the Green Bank Telescope in West Virginia and the Parkes Observatory in Australia. And by the way, I visited both of these. These are both my photos. But it's using other telescopes as well. They've released data recently of thousands and thousands of stars. Still no confirmed signals, but they've only, if you take all the SETI efforts up till now combined, they've only scratched the surface, or, like literally barely even, like a needle in a haystack, like searching just a few grains on a vast, beach, ocean beach. So the lack of a signal right now really doesn't tell us anything about the presence of alien civilizations. The searches keep getting better and better. The receivers now can sift through millions of narrowband channels simultaneously. So if there are other radio transmitting civilizations out there, maybe someday one of these SETI programs will hit the jackpot and it'll make big news. There's also several groups that are doing what's called optical SETI, which is searching for powerful laser signals transmitted by other civilizations. There's a group at the University of California, San Diego, that recently installed a near-infrared detector on a 1-meter telescope at Lick Observatory in California to search for these laser signals. They're also working on an even more advanced instrument to install on one of those large ground-based telescopes I discussed a few minutes ago. However, I would bet that if we ever discover other civilizations, I would put my money on technosignatures. And, this of course is, some kind of indication of a civilization modifying its planet or interstellar space. Now, it's really fascinating to speculate about technosignatures because it forces us to consider the activities of civilizations millions of years ahead of our own civilization. So, for example, in this artwork, we're seeing a space colony orbiting a black hole that's tapping the rotational energy of the black hole, which is enormous. So, we're nowhere close to being able to do this. I mean, we might be thousands and thousands of years from being able to do this, or maybe never. But who's to say what kind of astroengineering project a civilization millions of years ahead of us might be capable of achieving? And especially think, what if they have artificial intelligence that can speed things up? We really don't know. So there are a number of ways that astronomers could discover the technosignature of an extraterrestrial civilization. One possibility is that the telescope I told you about a few minutes earlier, Exolife Finder, or ELF, could find artificially produced gases such as chlorofluorocarbons in the atmospheres of nearby planets. Okay, so that would be pretty amazing. But one of the team astronomers, the University of Hawaii's Jeff Koons, said it could also take, in the infrared, do thermal imaging of cities on the night side of planets within a few dozen light years of Earth. So who knows what those cities would look like? Here's some kind of really cool far out art of what one of these alien cities might look like. I'm sure many of you have heard of the term Dyson sphere. In 1960, the great physicist Freeman Dyson, who died just a few months ago at age 97, popularized the idea that a highly advanced civilization could build a spherical swarm of space colonies that would orbit the star to harvest some or most of its radiant energy. So here we see an artwork of what one of these Dyson spheres might look like. Now, such a megastructure would have to give off heat, second law of thermodynamics. So astronomers could detect this heat in the infrared part of the spectrum. And in fact, astronomers have actually studied infrared data of other stars and even entire galaxies to see if they could find signs of Dyson spheres or other megastructures. And this is just, so far they haven't found anything, but this is just one of many proposed technosignatures that astronomers could possibly detect with current or near future telescopes. And we might not even have to look deep into space to find evidence of another civilization. So consider a civilization that arose billions of years ago and that endured for millions of years and developed highly advanced technology way beyond what we possessed. With that immense amount of time that is at its disposal, interstellar travel might be child's play. So one of our own astronomers, Penn State's Jason Wright, has pointed out that we can't even rule out the possibility that advanced civilizations have sent probes to our solar system and we would be completely unaware of them because we have barely even begun to explore our own solar system. So if you think of the book and movie 2001: A Space Odyssey, Arthur C. Clarke envisioned this scenario decades ago when he imagined this monolith buried right below the lunar surface, which, future American colonists discover on the moon. So if we start exploring the other solar system, or the solar system, planets and moons up close, who knows what we might find. And Wright has even pointed out that we can't even rule out the possibility of active or derelict alien probes orbiting the sun right now. Only a very vast and thorough exploration of the vast expanses of interplanetary space would reveal them. So once again, none of this is crazy if you accept the idea that other civilizations might exist, and then some of them might exist for millions of years. If you accept those possibilities as being, something that could be true, we cannot even rule out the possibility that Earth is being observed right now. So I just want to conclude by saying that a conclusive discovery of another civilization, I think, would be a really big deal. If the civilization is far more advanced, which is highly probable, it would give us reason for optimism that even a relatively primitive civilization like ours can survive technological adolescence. And if we can learn something about this civilization, it might answer the question of whether humans have a post-biological future where we might merge with machines or produce artificial intelligence that takes our place. And confirming the existence of another civilization might have profound ramifications in ways we cannot predict, especially if we can get some detailed information about the alien society. And even detecting primitive extraterrestrial life, I think, would be incredibly fascinating. It would give us insight into our origins and the types of planets and environments that can support life, and what kind of alternative life forms might be possible, life that might be radically different from what we have on Earth. But imagine we go decades and search for extraterrestrial life with better and better technology and telescopes, and we come up empty. Even that negative result would be interesting. It might be disappointing, but it would be interesting, but it would imply that something rare or unusual happened here on Earth. So I think that no matter what we find, the search for life on other worlds is going to tell us a lot about ourselves and our place in this wondrous universe. So I want to thank you for your attention, and I will be happy to field questions.
Hey, thank you very much, Robert. Yes, catch a drink of water. That was a good presentation. I have a quick, you can hear me, right?
Yep, no problem. You can still hear me.
So how does Big Joe become your favorite rock on Mars?
I just like the name, and
okay.
And even though my name isn't Joe, and part of it is the Viking landers landed in 1976. I was 13 years old, and I was old enough that I could really appreciate it. Like when I remember the Apollo missions, but I was younger. I was kind of a little bit interested in space, but, very unsophisticated. But with Viking, I really understood, like, we've never landed on Mars before. What does Mars look like? What are we going to find on Mars? I was old enough, because I was interested in science, that I could really appreciate it. And of course, these early pictures from Viking 1, Big Joe was the main rock. And so I just fell in love with Big Joe. Now, I should point out, if Viking 1 had settled down, it's parachuting down. If it had settled down on top of Big Joe, end of the Viking 1 mission. So fortunately, Big Joe, as I remember, is like a few tens of meters or something like that away. So fortunately, it came down near Big Joe, but not on Big Joe.
Right. Do me a favor, Robert. I need you to unshare your screen now. There should be a button somewhere.
Yep.
And normally I'd hold questions to the end, but I thought there's something we can do on this format, everybody, under more. If you have a question, you might try doing what I just did. It should work. You can put like a hand up, or you can put something up that you want to ask a question. Dan, if you're there in the background, can we just unmute everybody for a minute? And then,
Sure.
Maybe we could do a question that way too.
Like your background screen there, Ted, with the Roger Dean from like some of the Yes cover artwork. I like
Roxanne Kamen, who's our guest speaker next month, caught that for me too. I told her I was going through a Yes revival listening to this all during COVID. So yes.
Ah, great. Yo, I'm a big fan of Yes too.
Well, tell people where your picture's from. By the way, the picture you selected looks stunning while you were doing this talk, especially next to your pictures. But where's that one come from?
I took that just a few days ago, right out my front door of sunrise in over Hershey, Pennsylvania. So I took that, literally, and the first two of these Zoom talks that I gave to two other astronomy clubs, I told Ted earlier, I didn't like have a background. Like my background was just my wall. And so I want to thank Ted for showing me how to do this to create a more interesting background.
It looked good. You'll like the video with the playback. You look good on it. Yep. It came out.
Okay, great.
Okay, let's do this because I know Denise wants to do a little bit of a talk, and I have just a little bit lined up. Does anyone have a quick question they might want to try? Okay, Al, go ahead.
And I can stick around until the end and take questions later. And that'll give me a chance to grab a beer too.
Thank you. Yes.
One of mine. Question and one observation. I was sad to hear that Freeman Dyson passed away. I didn't know that.
Yeah, I think he died. I think it was in February. But he definitely lived a very. Yeah, he lived a very long and productive life, though. But he made it to 97, which is. I doubt I'll make it to 97. I don't live a healthy lifestyle.
We all had the joy of meeting him. He commemorated our first opening at Muddy Run Observatory.
That's right. Yes.
Yes. Exelon foot the bill and actually took him on a limo drive all the way out to the observatory, which was absolutely great. And yes, he was out there. I was going to bring up the Dyson sphere if you hadn't addressed it in the talk, because it's interesting. I had brought a couple of the club members had said that too about, we should play the Star Trek adventure that he was, in. And when I did bring it up to Dyson, he said that the idea, let's just say, played out in Hollywood much more grander than he had imagined it. So he said, I can't really take credit for what came out in that science fiction thing because it was much more grandiose than what I had thought of. And then he also said, no, let's avoid that. So I thought, okay, no problem.
Now, do you have a recording of his presentation? Because if you do, I'd be very interested in watching or listening to it.
Do we, Al?
Dan recorded it, didn't he?
Dan?
I have. Yeah, I'll get it to you.
Oh, great.
Really?
Thank you. That'd be great. Yeah, I'd love to hear what he had to say. I mean, I haven't read any of his books recently, but I remember maybe like 20 years ago, I read his book, Disturbing the Universe, which was really interesting.
Well,
Dan, think about this. We could do a commemorative about him. I'm sorry, I'm talking over Al, but we could talk. We could post that video link to Dyson, the talk we had done, and just do it as a commemorative. We could put it on the Muddy Run site. Sure. We could also put it on our site. Mm-hmm. I'll talk to Dan about it afterward during the week, and we'll see if we can't figure out how to get that to happen. But yeah, that was kind of interesting. That was a highlight of me being a president here because I was scared to death to talk to the guy. I really don't understand all of his work. And okay, so my members have heard this, but I walked in with the book Physics for Dummies. Mm-hmm. And I put that on his desk and I said, Freeman, I said, I get lost somewhere around chapter 13, 14. I said, even I can't get through this book. And he was good with it. He bonded with me in a different way. We had fellow friends that helped him build the observatory. He built an observatory up in Washington Crossing State Park for the Princeton astronomers.
Oh, wow.
He was a bricklayer, and he actually built the foundation. And that's why he came out to Muddy Run, because he said to me that one of the most amazing things he ever did was build the observatory, and it lasted longer than any of his ideas did, because it's like 60 years old now. So.
Oh, wow. Congratulations.
It was a lot of fun. Yeah. It was a lot of fun meeting him. So, Denise, are you out there somewhere?
Well, I think Alan had a question.
Oh, okay. Go ahead, Al.
Okay, can you guys hear me all right?
Yeah.
Yeah, okay. No, it's not really a question, it's more of a comment. All this big deal about Venus and stuff. I think Venus is kind of like practice getting ready for this transit spectroscopy, because if this had happened with transit spectroscopy, everybody'd be going nuts. But with Venus, we can do more easily, follow-ups with landers and, just atmosphere samples. Just a comment.
No, I agree with that. It was interesting because the article I wrote for Astronomy magazine, I had 3,000 words, a lot of ground to cover. So I wasn't aware of this result, but I was aware that there's been speculation dating back to Carl Sagan in the 1960s that there could be life in the clouds of Venus. But I decided I don't really have room to cover that in the article. So I kind of feel like, so the article comes out and a couple weeks later, we may have found life on Venus. So I kind of feel a little bad about that. But, the scientists, I did email several scientists just, last week after the result came out. And, I've gotten mostly, no one's, the general view was we think that the phosphine detection is probably okay. It was made by 2 different telescopes, but it was only made at in one region of the spectrum. So there's questions about how robust the detection is, although it's probably real. But, the message I was getting from these scientists, one of them is Chris McKay at NASA Ames, is we know almost nothing about the chemistry of that particular layer of the Martian atmosphere, other than there's not a lot of water at that altitude, but there's a lot of sulfuric acid. There could be all sorts of other trace compounds that, the mixture of the chemistry there could produce phosphine. So you can say, yeah, phosphine is on Earth. It's definitely a biomarker for Earth, but we just don't know right now about the chemistry of Venus's atmosphere to really rule in or rule out life right now. So I think it was not irresponsible of the team to announce this, because they made it very clear we are not claiming we discovered life on Venus. They needed to throw the result out there so other scientists are interested. So like NASA and ESA, Japan, China, and other countries that fly interplanetary missions get interested to do a follow-up.
Right.
So I would say it was totally okay for them to do what they did. But if I had to bet money, I would bet that they probably did not find life. But I would not want to bet a lot of money against it. It's possible that they did. And, it could be it's sort of a primer with the exoplanets.
Exactly.
We can find things that would say, okay, there could be life there. But, once again, if you find a planet that's the right size in the habitable zone, and you find things, let's say, like Earth, or certain combinations of chemicals, you might not be able to prove that there's life, but it would probably be, especially if we start finding a whole bunch of planets with similar signatures and they're all in the habitable zone, and let's say planets that aren't in the habitable zone don't have them, you start getting things like that, and you're going to probably say, okay, we can be pretty confident we found life. My guess is the first 1 or 2 planets that they might think they found life, it might not be that convincing. But if you start building up like an inventory of like a dozen planets, then it starts getting pretty compelling. That's how I kind of see it unfolding. Does that make sense?
Thank you. Yeah, fine.
And you made
Thanks for
your comments, very, very well taken comment.
Yeah, okay. Well, thanks for, being at our meeting.
Yeah.
Appreciate that.
My pleasure.
Well, hang in there with us, Robert. I'm going to hand it over to Denise, I believe now.
Okay, I'm just going to grab a beer. I'll be right back.
Okay.
Yeah, give me a second. Can I share my screen? All right, let's do this one first.
It's coming through. Yep.
All right.
Pinch out for bigger view. Yep. I'm kidding.
Can everybody see that? You guys, I can't pinch out because I'm not on an iPad, but This is the first meeting of our academic year, so hi everybody. Thanks for coming. And happy fall. Tomorrow is the first day of fall, the autumnal equinox, and that is the exact moment that the center of the sun crosses the celestial equator. So, and the sun's actually heading southward now because our nights are going to get longer and our days are getting shorter. So that's good for us astronomers. So we get some more gazing time, which is always very nice. And I'm going to show a couple planets that we can see, but first I wanted to show heavens above. This is where I was able to tell you exactly where the space station was going to be. First off, I go to spot the station, and you can put your email or your text or your phone number in there to get a text or an email when you're going to have a nice pass. It usually only lets you know if it's going to be really bright. And you can log in. If you can see my mouse here, you can over here, I have it set for Philadelphia, but I can put it for the observatory, Albrightsville, or Swarthmore where I live. I usually use Philadelphia. Then you go down here, here's your lists. That's only if you log in, it's free. So just make it a little account so you can do that. And then you go to ISS. It also tells you lots of other satellites, but if you click on the date, not only does it give you all this information here, but I find this one helpful because it shows you the exact path that the space station is going to take and the exact time it's going to be there. So it's very helpful. It's Heavens Above, Heavens-Above is the website. And there's another pass that we can see. It's not as bright, half as bright at 21. Yeah, I have to count on my fingers. 9:08, I guess that is. And we can see where that one's coming. I probably didn't get a text alert because it's going to be very low on the horizon. So if you have a really good view of the sky, you can see it when we're done our meeting. And then same thing for tomorrow. It looks like there's going to be a nice one. You can get these. So these are great images. I think they're easy. I have debates with Mitch, in our group. He doesn't like those maps. He thinks that people can get kind of cross-eyed when they start looking at a star map, but I think it's really easy, and it's like, oh look, it's passing the North Star right at 7:33. So I find those helpful. So once again, that's heavensabove.com.
It helped us, Denise. Thank you. You got us
you're
to see the
welcome.
space
Not
station.
everybody knows they have a satellite app or something like that, but I think that web page really, it helps me. And not, like I said, I can put it because it does move a little bit. If we went to Holtwood, it would, be just a little bit off from where it is in Philadelphia. So it's really great. And you can say, oh, look, it's going right past Jupiter, and tell your friends and family, and it makes it easier for them to see as well.
Cool.
And speaking of Jupiter and Saturn, I thought I would just bring up the star program. So let me share my screen again. Stellarium. And I'm going to move you guys over this way and hopefully make my screen bigger so everybody can see it. So obviously lately we've all been looking at Jupiter and Saturn down here in Sagittarius heading into Capricornus. Jupiter's been really, really bright. And I just read an article today that some Canadian scientists actually think they found a couple new moons, and that there could be up to 600 moons orbiting Jupiter. So I don't know exactly what they're counting as a moon, because I'm sure a lot of them are tiny little rocks, but still kind of fascinating. I wouldn't put it past us finding a whole bunch of stuff out there, kind of what Robert was talking about. I was blown away when he made me think about it, because I never thought about it. There's all those extra solar planets out there, but those planets might have moons too. So that it doubles, triples, even quadruples the amount of places that there could be life out there. So pretty fascinating stuff, Robert. Thank you. I never really thought about the moons of all those planets. So could be lots of life out there. We also have the Planet Mercury will be popping up a little bit in the west at sunset, and Venus is up in the morning. And I don't know if you've seen Mars, and I'm not crazy about Mars in a telescope, but if you stay up a little bit, you know, a little bit past midnight, it's nice and high. It's right in Pisces, and it is really bright, and it looks really, really pretty. I'm sure it was beautiful out at Cherry Springs, Ted. It was nice from my driveway last night when I was putting the trash out. So I enjoyed it. And if you stay up early in the morning, you also have Venus, and that's up right before sunrise. So that's something, if you're an early riser, if you're getting up to go to work, or, you know, whatever you're doing in the morning, having coffee outside on a brisk morning looking for Orion, then you might as well stay up and look for Venus as well. So happy solstice or equinox, everybody. That's tomorrow about 9:31 a.m. Some of you might know that I'm into the instant in time, that the things happen because you think the equinox is an entire day, but really it's just one brief moment in time. And we have lots of those, and hopefully we can make all those brief moments wonderful together for the new year. So thanks for listening, and
thank you, Denise. Thank you very much. Hey, Dan, let me go a little bit here. Are you still in the background?
I'm here. Yep.
Okay, I can't see all the pictures on this one. I was going to try this for a second. I'm going to share my screen. See if I can get this to happen now. And no. All right. Is this upside down to everybody else or just me?
Nope, you're good.
Is it upside down to you guys?
No, it's good.
Okay, well, hold on. So I'm upside down. All right. Well, let me see if I can turn it around.
Ted's using Sky Safari. I was using Stellarium.
Is it still okay, everybody? Can you see it?
Yours Sky Safari is really pretty.
Okay, so what I was doing, I just wanted to show you a couple star clusters that I've been catching. I've been practicing with this brand new camera of mine, and what's interesting is you get, I was limited looking over in the north, and not a lot of people look north. Everyone always wants to look south. I'll give you a good one, everybody, in your binoculars. If you haven't looked at Merfac, or the Stellar Association of Stars, or there it is, Merfac, or the Stellar Association of Stars around it, it really is an amazing region, and it really is a pretty binocular site. I know a lot of you might be trapped at home and you might not be getting out of the city. These stars are bright enough that in a pair of binoculars, you can really see them. Now, here's the catch though. A lot of people don't understand, well, it's not really a star cluster, it's a stellar association. We don't have a lot of these in the Milky Way galaxy. Our sun has an association of stars with it. These are more common in the Andromeda galaxy, which has a couple massive of these associations. Well, here's the catch. To be defined as an association, they're all moving through space and time together, but we haven't really observed any of the stars gravitationally bound to each other. While they're all moving together in space, that's why we call it an association, it's kind of like a time game. We haven't observed it long enough to be able to tell if the stars are gravitationally bound within that cluster. So these stellar associations are like the biggest star, let's say, masses in the galaxy. Don't forget to check out M34 over here. It's a neat little cluster. It comes out pretty neat. You can see it as like a little pimple of light up there in your binoculars. It also is an easy one if you're playing around with astrophotography to get a picture of. I had a couple of instances. I was, of course, Andromeda's overhead for everybody. When we're out in Wyoming, and I hate to push this, it really is 6 degrees across the sky. You could put 2 fingers up over the core of the galaxy, and you could see the galaxy sticking out just a little bit on either side. And of course, it's easy to pick up M110 out there and M32. And this is the first time that I'd gone out there I did a 30-second photo of it, and you can actually pick up these dust bands on both sides of the galaxy out there pretty easily. The one thing, though, that is different between Wyoming and Cherry Springs, Wyoming has a black sky. Cherry Springs has a deep navy blue sky. So there is a difference. They don't match each other. But as far as the number of stars you see, I'm not so sure it's that different. Here's one that a lot of people overlook, and I'm going to highly recommend this one if you have a beginning telescope or binoculars. Everybody spends a lot of time looking at Andromeda, and that doesn't really impress your friends if you show them this in binoculars. Even sometimes a telescope view, it's not that impressive. Remember, in the telescope, you're just going to get the core, just about the core of it lighting up, and that might be all you get, especially with some of the city skies around it. But this one down here, NGC 752. There's a beautiful open cluster of stars right here, about 40 of them in association together. And it's in a very common area. It's right between, Andromeda and Triangulum, which some of our friends were trying to image this weekend up at Cherry Springs also. The Pinwheel Galaxy right there, which is in Triangulum. So these are a couple of neat clusters. So disappointing when you come home and the double cluster disappears from the sky, but I'd say anywhere out in Iowa or in South Dakota or Wyoming, you can just look up and you can see the double cluster. It easily stands out in the sky as a naked eye object. We even were able to point it out with our lasers out there, and people could see. They don't see two. In fact, when you see it in the nighttime sky, it just looks like one bright dimple of light. It looks kind of elongated also. I'm not so sure you can really see that there's two clusters, just that it's elongated side by side out there. So Queen Cassiopeia always has some neat sights to it. And here's one I always kind of caught my fancy. So you all probably look for this one here if you're looking down Messier objects, M103. M103 is no great shake. It really is just like a little triangular shape of stars right there. It really doesn't stand out at all in binoculars. So Charles Messier has that one on the list, but the one that's really neat to take a look at is NGC 663. Again, another beautiful open cluster of stars right there. This one comes out really nice in binoculars. And I think I just got another astrophoto of it recently. I might share those at one of our AstroCora nights. So if you're looking for some sights right now and you're looking around the nighttime sky, northern sky, don't overlook it. It's pretty good. Now remember, over there in the east, we have the Hyades and the Pleiades clusters coming back up. And I must say that I learned a lot more this year about this whole location of our galaxy because, let me see if I can find it. So most of you know that when you're out at Muddy Run with us, you can see the Milky Way, and you can see this dark band. It goes right up the center of the galaxy here, goes right up through here, and it tends to like drift out right around Cygnus the Swan. I didn't think it actually went much further than that. When we're out west, this entire region over here, below the elephant trunk, right behind that North American nebula, that's a really dark area that really stood out to me up in Wyoming. I just wasn't aware of it as much. And even when you look over towards the King and getting over into Cassiopeia again, I didn't know you could actually see some of that dust band. And it actually shows up in this picture that I'm showing you, but you actually can see some of the dark dust back there between M52 and where it has Cassiopeia's chair right there. So I want to give you a little bit of sights. I know the normal ones at this time of the year are the Andromeda Galaxy or the Great Globular that's over here in front of the horse there. That might be something that we try to get up at Muddy Run and take a picture of that and maybe get it online at our next open house, which I believe is scheduled for Saturday. And that's if we get the internet connection and everything running up there. So don't overlook your northern sky. It's actually kind of neat. If you look over in the evening sky, we're getting back around to the late summer, it seems, or early winter, because there they are, M37, M36, M35, the starfish, the pinwheel, all those neat clusters all together. No, you can't really see them naked eye out in Wyoming. But what does really stand out in Wyoming is this one down here, not the starfish. This little thing down here, it doesn't even have a name on it in this thing. I'll hit a couple of these stars here. I think Joe once called this the minnow, and it looked like a little tiny fish, or a guppy it's sometimes called. That stands out really bright up there. But no, you can't see the pinwheel or the starfish cluster. You can't see those naked eye. But again, wow, here we go, everybody. We're coming around into winter. So if you're up at 3 in the morning, you're already seeing Orion and Betelgeuse coming up over the horizon, and And like I said, Venus has been great, and Denise had said it too. Been a really nice early morning sky view. Okay, let me stop sharing the content. And I think, did I stop the broadcast?
Yes, you
Is
did.
anybody there? Am I back?
Yep.
Okay, I'm back. All right, so that's all we have for our meeting, but I see Robert's still up there in the corner. And if anyone has any questions for Robert at this time again, did you think of anything while I was talking? Would you like to ask anything? You'll have to unmute yourself if you do. Go ahead, Henry.
Okay, two questions, one practical and one for the speaker. The practical question, how much magnification do I need to see the ISS as more than just a bright light?
I read somebody said that they could see solar panels with binoculars.
I tried that with binoculars and all I could see was fringes from the bug screen on the kitchen.
Maybe they had, well.
Because I wasn't rushing outside. They just went, and yes, it was clearly visible with the naked eye in a sky where nothing else was yet visible. So even with binoculars, all I was seeing was a bright spot.
I have seen it cross my field of view when I was observing the moon. And the only reason I knew it was the space station was the panels that kind of stick out that make it look like a winged flyer. But it went by so fast that I didn't have any camera gear or anything to catch it. And it was pretty low power. So you can see it against the surface of the moon with a low power telescope.
Okay, worth hunting for with low power telescope.
Worth hunting for a moon pass,
Not
yeah.
with the temperature already down into the 40s. Okay.
Denise, have you ever seen it on the skies above that it would actually show you a moon pass?
It does tell you stuff like that, yeah.
Okay.
Yeah.
So Henry, look at that Heavens Above website, because it'll tell you when it's going in front of the moon. Maybe you'll
Oh
catch
yeah,
it.
it'll definitely, because the moon will be on the star map, yeah. So definitely check that out.
Okay, and one for the speaker. Robert, you were suggesting the possibility of detecting an alien civilization by artificially made chemicals in the atmosphere. But given the concern on this planet about pollution of the atmosphere, isn't there a significant probability that any truly advanced civilization would avoid from polluting its atmosphere and would look at that level exactly like a planet supporting life but not supporting any civilization? You've got your mute on.
You hear me?
Can now.
Can everybody hear me okay?
That was your question, Robert. Go for that one.
Yeah, that's a really great and interesting question. And, you know, this gets back to what I said, you know, during my talk is, you know, when we're thinking about techno signatures, you know, we're thinking about alien civilizations that, I mean, it's not just the technology, it's their mindset and the way they organize their society and what they're made of. I mean, I just really threw that out, the CFs, the chlorofluorocarbons, because that's an example of a chemical that nobody can think of how you would produce that naturally. That would be something that would only be produced by, you know, some kind of, you know, industrial process. So that would be one that you could look for. But I think your point's very well taken. I mean, you can argue how advanced are we? You know, we're in the, I mean, and I've read a lot about this. I mean, I could give a talk to your club. You know, we're in the process of destroying Earth. I mean, I don't mean to get political here. This is the truth. We are destroying our planet. I just read a big article about this yesterday. And you would hope that if there's other civilizations out there, they've had to have gone through a period, or you would think that they would have gone through a period where they develop high technology and they get through that period and they don't destroy their planet. And there's speculation, a lot of them would not want to go out into space. They just stay back on their home planet and kind of try to hide and not call attention to themselves and just get into like philosophy and art. Now, those civilizations, we might never be able to detect them until we venture out into the universe, or if our machines or whatever venture out. But I basically agree with the premise of your question, and it's definitely a situation where, if there's a lot of civilizations out there, some of them might like hibernate or go into hiding. Others might try to venture out in the galaxy. We really don't know what to expect from other civilizations. I just want to add that I did not really get into the Drake equation or questions about how common civilizations might be, because it's my position that we simply do not know. We simply don't know. I mean, I've seen compelling arguments that Drake equation, n equals 1, we're the first civilization to emerge in the galaxy, or maybe a few others have emerged before us and destroyed themselves. But I've seen equally compelling arguments, that there could be hundreds or, maybe several thousand. I don't think there are millions of them. If there are millions of them, we would know it by now. But we can't rule out there could be hundreds or thousands of them, and we wouldn't necessarily know. So I think it's a complete unknown, and therefore it's an observational question. And, there was a guy, when I worked at Astronomy magazine in the 90s, there was an astronomer who was getting his doctorate at University of Wisconsin named Chris Consolis, who I became friends with. Well, he's now in England at the University of Nottingham. He came out with a big paper about a month or two ago where he calculated the number of civilizations in our galaxy. And, I read he asked me to read his paper, and I did. And it's all nonsense. Don't tell him I said that, because you have to make assumptions on those terms on the right side of the Drake equation. And we have no idea. Like, we know what the terms on the left side of the Drake equation are. The astronomy has answered those questions, but it's the questions about lifetime of civilizations, what fraction of planets develop intelligent life, and what fraction of those planets decide to communicate. Those questions, we have no idea what the answers to those terms in the Drake equation are. So without knowing those terms in the Drake equation, we have no idea what n in the Drake equation is. So I kind of, I used to really be interested in that, but now I think it's just an observational question, and we have to do this through observations, not through calculation.
It's not true we have no idea. We have one idea. We are not overrun by little green men.
That's true. Yeah.
It sets an upper limit on something.
Yeah, but we don't really know. And there was also the famous question posed by Enrico Fermi, where are they? And, that's an interesting data point. Like, we don't see the galaxy overrun with multiple civilizations or one super civilization, but there's all sorts of ways around that where you could still have a galaxy with significant number of civilizations that we don't see. There's a lot that they don't call attention to themselves, all the way to they're aware of us, they're observing us, but they're practicing this prime directive in Star Trek, where they're not making themselves aware of making themselves aware, or to make itself observable to us. So there's all sorts of ways around the Fermi paradox and still have a lot of civilizations in the galaxy.
Right, but one of the valid solutions is that the only way you get through our current situation is in effect by becoming navel-gazing Buddhists who are very careful to observe everything and interfere with nothing.
Nothing, yeah.
It makes them extremely hard to detect, however, even if there are an awful lot of them.
Yeah, I would agree. I totally agree with that. There could be a lot of civilizations out there that just simply, they kind of get to the point where we are now, And it's like, okay, if we keep going along this path, we become detectable, and maybe we don't want to be detected. So, you know, and they could find other meanings to their existence in life that would not involve modifying their planets, where they don't have motivation to send out radio signals or laser signals. You know, and there's also the idea, and this is the concept behind Fred Saberhagen's Berserker series of science fiction novels. I haven't read them, but I've read about them, that you could get one civilization that, you know, arises and realizes that any other civilization that arises is immediately a threat, and just starts extinguishing civilizations as soon as they reach a certain level of development where they become threatening. So that's called like the paranoid universe scenario. And in that case, other civilizations might have reached that conclusion and just say, okay, we've reached this scenario, and we're going to become, as you were saying, more like a Buddhist civilization, and concentrate on, you know, just, you know, inhabiting our own planet and coming to terms and at peace with our own planet and living in harmony with the life on our own planet. That is, I absolutely think it's quite possible there could be significant number of civilizations out there that have reached that conclusion.
There's something comforting to me in that thought. Billions of civilizations that are just content to stay hidden.
That's could be, yeah. And then we might never find them unless we go out in the galaxy and, you know, and find them. But I mean, I would say on our present course, I'll be a little bit pessimistic here, and you guys can push back on me. I think we're in a race right now, whether we start finding life outside of Earth or whether we just destroy ourselves through, you know, destroying the environment and changing the planet's climate and atmospheric composition, or through, you know, nuclear war, or genetically some terrorist group genetically engineers a virus. I mean, there's also, I mean, we're doing so many stupid things right now as a civilization, and we don't have any real, you know, it just seems like, to me, I just get this sense that our whole civilization is spiraling out of control, and there's nobody applying the brakes right now.
Well, another valid solution to the equation is that there is, in fact, a single galactic civilization, which, for reasons we don't yet know, is deliberately keeping us out of the loop, but may bail us out if necessary. If you take a look at the congressional district map of Pennsylvania before the Pennsylvania Supreme Court put its foot down and de-gerrymandered it. Yeah. There is, in fact, a Klingon Empire class battle cruiser flying over Allentown.
Yeah, that's right. Yeah, and then there was
completely recognizable on the congressional district map.
And then we had the one right outside Philadelphia. Some of you might live in this district of Goofy kicking Donald Duck. I was actually, I've been involved a little bit in Fair Districts, PA. It's, you know, the map was totally insane, a totally insane map.
Yes, I remember you sharing with me,
origin of the word gerrymander, because one of the districts looked more like a salamander than anything.
That's right, yeah.
Anybody could think of.
Yeah, I mean, I just think our civilization is just kind of, it's, you know, it's not just the U.S., I just think we're in an unstable, you know, you look at civilizations of the past would rise and fall, and we're sort of in a position now, we're sort of a giant global connected civilization. And I think it's very clear it's unstable. So when it falls, it's not going to be, you know, like when the Roman Empire collapsed, it didn't really affect China or what was going on in the Americas. But now, because the global civilization is so interconnected, that when the dominoes start to fall, the whole thing will collapse. So that's what I think is going to happen, whether it happens in my lifetime or not, or exactly how it's going to happen.
And you don't think that the virus is that happening now? Could be.
Yeah. Well, the thing is, you know, think about if, you know, we've had like the bubonic plague, in which, like 50% of the people who caught it died. Imagine if this current virus, the lethality is like about 1%. What if it was 50%? If you catch it, you're going to die. And we'd still have people saying, well, I'm not going to wear a mask because it's infringing on my freedom. So
no, you don't need a 50%. 1% is fine.
Yep.
If people are unable to develop a long-term immunity, so that you're taking a 1% roll of the dice. And think how many times in the winter you can catch the common cold.
yeah, that's right.
The cold you caught was a 1% roll of the dice.
Yep.
You'd start seeing some significant numbers building up over a few years.
That's right. Yeah, if there's not a vaccine, it's going to kill a huge number of people. And
If you can't develop a long-term immunity, a vaccine
Right.
won't do you any good, because
Yep.
it would mean getting the vaccine every 3 months, and people just wouldn't do that.
I would. I would.
Yeah,
but you're
you'd
right.
be in
People
such a
won't.
Yeah.
Once a year, like the flu shot, you could just get at least a lot of people into the habit of you just get your flu shot and your COVID shot every October.
That's right.
Anything more frequent than that, really, it's only going to be the professionals and a few really zealous people, and that's not enough to sustain society.
Yeah. Speaking of rolling the dice, I'm going to give people a different analogy here, and that is Russian roulette. Okay, so imagine, like, the typical Russian roulette, you have a gun with 6 chambers and 1 bullet. So you have a 1 in 6 chance of dying. Okay. But imagine a gun with, let's say, 10,000 chambers and 1 bullet. So you play the game only once, you have a 9,999 chance out of a 10,000 of surviving. You wouldn't be too worried. But imagine you had to play the game every day. Eventually, you're going to pull the gun with the bullet. That's what humanity is doing with nuclear war. We are, every single day, the chance of a nuclear war it's a small number, but it's not 0. So every single day, we're pulling that trigger. And you read books and articles by people who are knowledgeable about, how the United States runs its nuclear weapons and how close we've come on multiple occasions to like accidents or miscalculations leading to catastrophe. You read those books and realize that every single day we're playing a game of Russian roulette. You quickly come to the conclusion that our days are numbered. I mean, I definitely think global warming is a very serious problem. I'm actually think it's more likely I will die in nuclear war than from global warming.
But
I'm more worried about that.
Have you looked at the statistics for deaths from meteor strikes, which on a statistical average kill tens of thousands of people every year?
Yeah. Yeah. But the thing is, the good news with meteors, and that's a very good point, is that the ones that are big enough to destroy civilization, that are like 5 kilometers or larger in diameter, we have found like well over 90% of the ones that could someday hit Earth, and none of them are going to hit Earth in like hundreds or thousands of years. So the really big one, it's the city killers that are the ones that are the most concerning.
Right, and that leaves the 5% you haven't found and can't find.
Yeah, but the thing is, those are like, it's highly unlikely that, and those are like, what happened is you find a lot of them early, and then it starts trailing off the discovery rate. But the probability of there being one that'll hit Earth in kind of the time that would be statistically worrying to us right now is extremely low. It's not impossible, but it's extremely low.
But there's always that base load level of undetectable stuff. First time entries from the Kuiper Belt or Cloud, interstellars. I've already got into trouble on this for pointing out that comets are the bringers of plague and the harbingers of catastrophe, and blaming interstellar comet Borisov for the state of this
Now, if an interstellar comet were to hit Earth with its high velocity, it would be absolutely devastating, because the devastation has to do with both the size of the object, what it's made of, and how fast it's going. And the interstellar objects are going incredibly fast. So if one of those were to hit Earth, I mean, even a relatively small object would be absolutely catastrophic. But once again, interplanetary space is an enormous volume of space, and Earth is a tiny target. So if we're going to get hit, it's going to be most likely something from within the solar system, most likely a near-Earth object, but absolutely something coming in from the Kuiper Belt or the Oort cloud would be coming in at a much higher relative velocity, and would do tremendous damage to Earth, and would probably create an event that human civilization could not survive.
Yeah, excuse me, Mr. Nye.
Yep.
Yeah, I just wanted to make a comment that the the meteorite that it was filmed in Russia a few years back, everybody had it on their cam and all. Imagine that happening in the middle of the Cuban Missile Crisis.
Yeah.
So it doesn't take a really big meteor. I mean, if you're an alien, you see a meteor hit the Earth and the Earth self-destructs. It's kind of crazy.
No, and I'm here. I'm going to make what you made a great point. And I'm going to make it even scarier. Okay, so that that exploded over Chelyabinsk in February 2013. Okay, well you can even see it in the Russian dash cam videos. It came in at a very shallow angle. If it had come in at a steep angle, like it just happened to hit Earth at a grazing angle, if it had, let's say, came in over Chelyabinsk at a steep angle, it would have penetrated much deeper into the atmosphere and exploded with the force of a megaton, several megaton hydrogen bomb. So imagine you're Russia, and suddenly one of your largest, a major important industrial city is suddenly
hit,
destroyed by something that looks very much like a hydrogen bomb. How long are you going to wait before you decide what you're going to do to react? Now, if the U.S., let's say something like that happened to the U.S., and let's say we had, kind of stable, rational political leadership, the U.S. has a network of Air Force satellites that would instantly recognize that object as extraterrestrial, because they would track it entering the atmosphere, would track its velocity, and would know immediately it's a natural event. But no other nation has that type of satellite network. So like Russia or China or Pakistan or India, something like that happens, they might immediately conclude they're under attack, and we don't know what they would do.
Mr. Nye,
that's a very scary scenario.
Yeah, excuse me. In the 1960s, we didn't have any of those satellites observing. So
that's right. That's
if
right.
That meteorite came at the wrong time, that would have been it.
That's right. And think of the 1908 Tunguska that exploded over Siberia. I mean, it's incredibly lucky that it exploded over an almost completely unpopulated area, at least unpopulated by people. But you imagine that, to modern day, it would have looked like a hydrogen bomb explosion. I think it was like a 3 to 5 megaton event. So something like that happens over a nuclear armed nation. And of course, the biggest nuclear powered nations happen to be big physically, so they're more likely to be hit, Russia being the largest nation. I mean, it's definitely a real concern. I mean, I'll give Russia credit. They didn't react violently. They kind of, and part of it, I think, was the video clearly showed what was happening.
Right.
But yeah, I mean, there's a lot of different things that could trigger an accidental nuclear war, not just that's one very worrying thing. I mean, your point is very well taken. But I've read about this from, what's the guy, the former defense secretary? Can't remember his name right now. I read a couple articles he wrote, and it's like, oh my God, this is so much scarier than what people realize. And, you know, the Bulletin of Atomic Scientists a year or two ago, they moved the clock like a minute to midnight. You know, the people who are knowledgeable about this are very, very, very concerned. And people think, well, the Cold War is over, the threats ended. That is not true. It is extremely dangerous situation right now, especially as more countries come online and develop nuclear weapons. William Perry, William Perry, the former defense secretary, just Google his name and go to YouTube and watch a video of him talking about the nuclear situation. And, you know, it's totally rational. You know, he's telling the truth, and it's really scary.
No, I'm not mistaken. I think Carl Sagan brought our attention to it years back. He was
That's
afraid
right.
of something incoming would be misinterpreted as an attack, and
That's right.
We'd all wipe ourselves out from a natural event happening.
That's right. And you know, once again, you know, he was writing mostly during the Cold War, and
Right.
people think because the Cold War ended that the threat went away. Well, the threat has not gone away. The threat is still very much there. You know, there's now Russia and China and even like North Korea, you know, and I've heard a talk by Richard Haas, who's head of the Council of Foreign Relations. And within a few years, North Korea will pose an existential threat to the United States. And if that doesn't scare you, I don't know what would.
Well, I hate to say this is the time we have to wrap up, everybody.
Okay. Unless, is there one last question?
Maybe
a happier question.
Anybody out there?
Just one comment. I recall reading a science fiction short story from the 1950s that was the flip side of that. Something had obliterated Washington, D.C., and this was written from the point of view of them looking over the shoulder of the man in the bunker with all the remaining buttons, and something didn't feel right. So he actually kept his finger off the big red button until they figured out that it had in fact been a meteor strike and not a sneak Russian attack.
So I guess we could just leave with the question unanswered that, well, what do you think? Would President Trump push the button, or would he hold his finger back and wait? Let's not answer that. Let's just let that go and think on that one.
Yeah. I was trying to avoid asking that question.
Yeah.
You make for a great evening, Robert. Thank you very much.
Yeah, thanks everybody for tuning in.
Manny, your background looks great. You picked a good one. You stick with that one. Fern, good seeing you. Alan, good seeing you. Howard, haven't seen you out there in a while. I think you were at the last one, but I'll just end on this one. Next month is Roxanne Kamen. She's going to share her experiences, a night with the Hooker telescope. She's actually rented the scope, and she's done a whole night of observing. I've talked to the woman, Robert, you know her.
I know her, yeah, she's great.
She's amazing. She has this giant Dob she takes up to Cherry Springs and has helped us see some amazing sights up there. So I had asked her, you know, what's the biggest scope she ever worked with? And she said the Hooker telescope. And she said, I'd love to share it. I do a talk on the Hooker scope. So she's going to share, you know, her experiences of what she does on a night of research on that one.
Well, I just want to add real quick that a few years ago, I went with her and several other members of the Astronomical Society of Harrisburg, and we went to Mount Wilson and observed through the 100-inch. But I also understand it's being threatened with fire right now.
Oh boy.
Yeah, with the wildfires.
So yeah, you know of Roxanne's travels. She's worked with a lot of different telescopes out there. We are scheduled to do an event, maybe live this Saturday night at Muddy Run. I know Alan's not on here, but I know they have internet trouble, so stay tuned. We'll see if it works. I do know how it eventually did work the last time. It runs right on the Muddy Run webpage. You just go to the web page and the YouTube video just plays right there. So when we put this, we're going to try it out in September. We're going to put Robert up there in October. So we're going to see how it works also. And then we're going to do a series of astronomers, you know, through November, December, and then into the next year. But Other than that, I look forward to seeing you guys on the Astrocora. Remember, you don't have to participate. You can just sit and watch. And, you know, one last idea I'll share with you. If we can get that other group working a little bit more, one of the things I'm borrowing from the other clubs is maybe we'll meet in an Astrocora session and we'll break out into 3 groups. One could be astrophotography, one could be binoculars and a basic telescope, and one could be, hello, I'm a new member. That way we can actually do a 15 or 20-minute segment tailor fitted to the needs of those people. And then maybe at the end, it all comes back together. So I've been talking it over with Dan, and so maybe we'll be working on a few ways of doing some breakout groups in that type of forum also. So hang in there with us, everybody, and hope I'll see you next month here, and we'll get the notice out again for that one. Robert, I'll be talking to you again, and like I said, if you want a private visit out of Muddy Run, I'm out there enough that I can get you in there also too. All right.
Okay, great. Thank you.
Okay.
Take
Well,
care, everyone.
everybody, I'm going to sign off on this one. I'm glad to see all of you. Dan, you want to shut it down in the background also?
Sounds good.
Cool. Thank you, everybody. Take care. Have a great night.
Bye.
Bye.
Take care.